To further confirm this claim, though, the authors wanted to experimentally remove the horns on a species that had this trait and observe if the ability to link reappeared. Pollinaria from the species O. solenoides were used, and the authors created two groups, one where the horns were left intact and the other where the horns had been removed. They then tested to see if the pollinaria linked after pollination events. They found that pollinaria in the group with horns never linked with other pollinaria, while the group that had the horns removed linked with other pollinaria 65% of the time. These results provided more concrete evidence that a function of these horns is preventing linkage. Next, the authors wanted to confirm that linkage of the distal pollinarium interfered with the ability of the proximal pollinarium to deliver its pollen. To do this, the authors took two species of milkweed, M. brachiostephana and M. odorata, and created two groups for each, one with the second pollinarium linked to the proximal pollinarium and the other with no linkage of a second pollinarium. They then observed if the proximal pollinarium was able to donate its pollen in pollination events. They found that in M. brachiostephana, the group that had the linkage of a second pollinarium donated pollen 60% less often than the group of pollinaria that did not have a second pollinarium attached. And in M. odorata, the group that had linkage of a second pollinarium donated pollen 54% less often. So to summarize, the authors found that in species that evolved horns, the ability to prevent pollinaria linkage also evolved. The authors also confirmed that the presence of horns prevented linkage, as well as confirmed that linkage interfered negatively with the ability of the proximal pollinarium to deliver its pollen. They also showed an example of how physical confrontation occurs not only in animals, but also in plant species. To relate this back to the concept of sexual selection, high male-male competition for mates, such as the presence of pollinaria from many different individual plants, creates sexual selection pressure that favors traits, such as horns, that help increase a male's ability to reproduce, increasing the frequency of that trait over time. This could have been the process that led to the evolution of horns in many milkweed species. We would like to thank you for watching our video and hope you enjoyed watching it as much as we did making it.
Created using Powtoon.